Welcome to the Rare Earth Exchanges podcast, where power, politics, and the world's most coveted materials collide. Rare earth elements power the backbone of tomorrow's most critical technologies. With China dominating global production, the U.S. and its allies must align strategically to ensure a stable future. This urgency prompted tech entrepreneurs Daniel O'Connor and Dustin Olson to launch Rare Earth Exchanges, a news and insight platform built to equip stakeholders and decision makers with the tools and intelligence needed to reduce dependency and build prosperous resilience. Let's get into it.
Hey everyone, welcome back to the Rare Earth Exchanges podcast. I am Dustin, your host, joined by my co-host Daniel, and today our special guest is Tom LaRochelle, who is the CTO and co-founder of L3 Process Development. L3 is a specialized consulting and engineering firm focused on the processing side of rare earth elements. Tom, welcome to the show. How are you doing?
Very good. How about yourself?
Good. We are excited to have you here. We think that what your company is doing is kind of really important, and we're excited to have you unpack that a little bit more with us. So, Tom, for our listeners who may not be as familiar with the processing side of rare earth elements, could you give us a high-level overview of what you guys do and how you fit into a project's lifecycle?
Maybe first we can talk about the actual project lifecycle that most of the mining companies or people in that industry wants to go through to bring their project to market. If we look at a traditional client, will be a junior mining company, was founded typically by a geologist that found a deposit somewhere, drilled a few holes, did some analysis, figured out that they have a resource that would be worth exploring and maybe developing. From that, they'll write a technical report, raise a certain amount of money, and move on the project lifecycle, which typically would consist of going to a commercial laboratory, doing some test work, figuring out how to extract any valuable metal. In this case, we're talking about rare earths. So how to extract the rare earths. Typically, you'll concentrate the rare earths, and then you'll do hydrometallurgy. You'll recover the rare earths. The first step usually will be a rare earth concentrate, and then you would move to separation. Once you have what we call a data book, which is what works to recover the rare earths from the minerals. The junior mining company will go to an engineering consultant firm to design the flow sheet to extract, and then they will run economics on the project. Now, if we want to talk about my background, I come from the engineering consulting background, so did very many projects in the last cycle of rare earths starting in 2011, where my client would have gone to the lab, done all the test work, come to us to do the engineering portion and the design of the flow sheet. Very often, almost every single project, once we ran economic on the design based on the data book, we'd found out that technically it works, but economically the client would lose money by doing that. So what we would do is then the client would ask us to go back and sit at the lab and work with the scientists at the lab, figure out what works and what is economic, and we would do that. So I spent a lot of time at the commercial lab developing flow sheet in a previous life. And at that point, one of two things would happen. Either we would be able to find what works and what is economic, would publish technical report, our client would be able to raise more money and keep moving on the project lifecycle, or they would run out of money, which is what most people experience. And then the project would stop. The client would focus not on developing the resource. It would focus on financing to be able to keep moving forward. So after a few of these projects that failed, following that traditional path, I teamed up with two partners and we started L3 trying to turn that project lifecycle around. So instead of trying to figure out what works, we tried to figure out what is economic based on the very large body of literature that's out there on all these minerals. If we step back on the rare earths, most rare earth will fall into one of 3 or 4 types of mineral, which the processing is fairly well known. You have monazite, bastnasite, ensolite. Everything else has not really been exploited yet in a different discussion. But basically, by figuring out what would be economic if it worked, and then progressing to the lab to see if it actually works and validate key assumption that we made in the design phase, we can reduce the timeline quite a bit on that process development. So what does L3 do? Essentially, we develop flow sheet. So we figure out the best economic way of extracting rare earths from the resource and then separating the rare earths, which we may get into later, using the same approach of flow sheet development. The second aspect that L3 does that is a little bit unique is we've built a design, fabrication, operation capabilities for pilot scale equipment and demonstration plant. Because what we found is as we move through the project lifecycle, very often when we want to pilot or demonstrate a process, might spend a little time on the difference between piloting and demonstration. Most people will use them interchangeably and they'll be like, yeah, we're piloting. And in the next sentence, it's a demonstration. Every time I'll say piloting, what I mean is a small scale circuit that one runs continuously, but the goal of piloting is to validate assumption that we made in the design. When I say, okay, we're going to do a demonstration campaign, means it's a fully integrated, scaled down version of the process that will feed real material at one end and will get commercial sample at the other end. So very often the unit operation to prove those continuous steps in the process at kilogram per hour scale are not commercially available, or it's a 6, 8, 12-month delay when you put the order and you receive the equipment. Most junior mining companies raise a bunch of money and then it's a drawdown until they can do the next raise. So waiting 8 to 12 months for a piece of equipment to do a campaign to get to the next technical report, you're not just spending the time waiting, you're paying all your overheads that is not bringing anything to the next race. So we've basically built a team that could design and fabricate those specialty equipment to help us move a lot quicker on the process. We don't have to find a supplier and then go through the purchasing process. We just design, build it, operate it. We've done quite a few of these in the past for our client. We've done some monazite, acid baking continuously at that scale. We've done some titanium carbochlorination. We've done some pyrohydrolysis, some pretty fancy unit operation that exists commercially at large scale, but that are very difficult to obtain to do pilot or demonstration campaign. And then the last aspect, which is sort of a side business for us, is because we've aggregated all that expertise in flowsheet development. A lot of people will come to us to do due diligence on project and get our opinion on, well, is this a good venture and how should we approach this potential investment?
That makes sense. And it's very important. So just again, for everybody, if you could just operationalize terms, we have a wide array of different types of people that are going to be listening to this. Define a flow sheet, its key segments, why it's important, and why it's often incorrect or needs to be updated.
So the flow sheet essentially is the instruction manual on how you take a mineral and extract valuable product that you can then sell on the market. On a rare earth project, the listener will probably be familiar with beneficiation, concentration. So that is taking the mineral and making a concentrate of the mineral, which typically will have a 30 to 50% rare content by weight, which will go to what we call the hydromet, which is essentially a combination of acid-base step and solvent extraction step to get a mixed rare earth concentrate. So that is going to be a pure product that has all the rare earths in it, either as an oxide or a carbonate, that then needs to go to a separation facility where the rare earth will be separate one from the other. Once you have the separated rare earths, then we go to metallization and alloying, which is another industry completely that we are involved a little bit, but not as much because our expertise tend to focus on the hydromet extraction and most heavily on the rare earth separation side of the industry for rare earths.
So on that, and that's very helpful, Tom, very, very appreciative and very important. On that note, what would you say is the most biggest challenge area within the flow sheet process? Like what couple areas do you find do miners underestimate or investors underestimate? The complexity and therefore the cost, the duration, the overhead in terms of labor.
That is a difficult question. Traditionally, separation would have definitely been that portion that has always been assumed that it's been working for 60 years. It's a legacy technology. How hard can it really be? Until a company went into a lab and tried to develop that flow sheet using the conventional approach and realized that they'd be looking at a 5-year process to get something that could be designed and built. Now, I say traditionally because one of the things that we did as we started L3 is develop a specific expertise in modeling of these circuits. So rather than doing 3 years of bench scale test work and hundreds of experiment, followed by 2 to 3 years of piloting, we've developed a theoretical simulation approach that uses a very limited number of experiments that we can do in the lab. And we've built a series of equipment to derive we call equilibrium constant, which are essentially parameters that drives the series of equations that allows us to use a computer to simulate how the system would behave in a commercial facility. Now, this is not new conceptually. The Carister group in France has access to very good and efficient simulation software to do just that, but it is restricted to nitric acid media, which has advantages and inconvenient. One of the inconvenient is you have to use stainless steel for all your equipment, so it drives the capex quite a bit higher, and nitric acid is quite a bit more expensive than hydrochloric acid. What we did is we built our own tools to do that simulation, but using any media. So we can simulate nitric acid, hydrochloric acid, sulfuric acid. Also, we've done many projects with, although separation tends to be a little more complicated, but many of the upstream flow sheet for rare earth recovery that would typically go to a mixed rare earth concentrate, if we integrate a solvent extraction circuit, we can do partial separation and really increase the value to the project at that point by making a light rare earth and a rare earth concentrate when that's possible directly from the hydromet. So those clients don't necessarily need a full separation plant. They might just integrate a simple NdPr separation circuit to their hydromet flow sheet using those techniques.
Yeah, that would be that, and that was very helpful. I think that one of the assumptions I was operating under is that, and you sort of, I think, countered this a little bit, but that each geological source to some extent is different, but there's patterns, right? So monzonite, what have you. But how much variation is there by geology? Can you are there templates that sort of keep you within a 90% range when you know the geology, or does it get even more complicated on the geology piece?
So the reason when I started working with rare earth a while ago, sort of fell in love with that field, is that when you mine rare earths, you're actually not mining rare earths. It's usually a few percent in the
Right,
mine. Like if you
right.
can 5%, that's a really, really high grade deposit.
Yeah,
So really what you're dealing with is impurities. So what
yeah,
are the metals that you need to remove before you can get to where you're at?
yep,
It's all over the map. And to answer your question, usually it'll depend on how you can concentrate the rare earths up front. And if you can't concentrate the rare earth up front, is there a technique to selectively go after the rare earth without spending too much capex or opex? Those are truly deposit by deposit. Now, that being said, if you can concentrate the rare earth either into a monazite concentrate or a bastnäsite concentrate, once you have the concentrate, the rest is pretty boilerplate.
okay, okay. And in terms of just on that note, while we're talking about it, one issue that comes up quite a bit is the radioactivity, whether it's thorium or uranium. I mean, do you all, I guess, how big of a problem is that really versus how much do people make it a problem? Because sometimes I hear that, oh, our feedstock is limited amounts of radioactivity, but it's hard to know what's real.
Yeah, it's a jurisdiction and mineral dependent question. I'll give you a few examples to explain that. We have client that are in the Great Canadian North where you have to take the material out of a very remote mine site, or you have to build a facility at a very difficult place. What do you do with the radioactivity? Once it leaves the mine site, typically it's a lot more problematic than if you can extract it and put it back in the mine. If you can basically put it back in the tailings without increasing the concentration or mobilizing it, it's a pretty easy discussion. We have client that during the process, it just goes in the tailing and it's not more concentrated after the process, and it's immobile. So it's never going to go anywhere. That's very easy. We have client that we extract it and we concentrate it because that is the only way to recover the rare earths and make a sellable product.
Right.
Now, in Canada, there are some places that you can pay to dispose of thorium and uranium. That's a lot easier. In the US, it's very complicated.
Right. Yeah. There's very few depots or locations that you can deal with that. So if we, take a look at, if we look at the number of new mines that are being looked at today, let's say there's geologists out there, there's investors they're talking to. I would imagine that a firm like yours should be involved pretty early in the process, right? Because it would be very costly if you do this thing incorrectly.
Yes.
Can you talk about that? Like what's ideally, and again, we're educating people here, whether it's through a firm, your firm, or through resources internally that know how to do this. Like what is the timeline or the life cycle of when these services come in ideally?
Ideally, as soon as the reserve or resource technical report is published, the next step would be to involve us to figure out what the best process development pathway is. Now, our company has a very strong focus on hydrometallurgy. So once you have the concentrate to go downstream, so very often what we'll do is we'll assist the client and then we'll go to a more established commercial lab that is very strong into those mineral processing equipment and leverage that expertise that already exists in the market, but supplement it with our development approach. That way, we don't do a lot of tests and then figure out if it's going to make sense economically. We can out drive the test program from the get-go using that approach, even though we might not do all the tests in that scenario. Our goal is really to bring the project closer to commercial as fast as possible so we can minimize overhead costs.
That makes sense. That definitely makes sense. Out of curiosity, I
So
mean, if you go ahead, Dustin, go ahead.
So kind of related to this, I was curious, you've worked with other companies like Niocorp, Commerce Resources, Aclara. What is your experience working with them kind of tell us about the readiness of companies for processing? Like how far away are we from that?
It's a client-to-client discussion. Niocorp announced that they were starting to build their mine portal last month, so they are actually already digging. So processing could be just a few years away, could be 2, 3, 4 years, depending on the section of the plant and how the project progress and financing, all those caveats. Aclara has a very aggressive timeline that they think that they can start separating rare earth within 2 years. And when we look at the design and the approach that they take and how we work together in partnership, and I don't see a reason technically why that would not be possible.
That's great. That's reassuring because I feel like we hear a lot of hype, but to have kind of a third party kind of come in and say that, well, every project, every client is different. They're technically sound. They could pull it off. So that's great.
Yeah, I mean, I think Aclara is a very good example. Niocorp is probably also one of the best example out there that I can talk of because I have intimate knowledge about what's going on and where they're going. And if you're interested, we can talk about both of them. Aclara just had their demonstration plant opening last month, so that's maybe a little fresh to the listeners. We were able to conceptualize the separation flowsheet from their Carina project in South America that they are actively working on the feasibility study, which I'm assuming it's going to be coming out any day now and it's going to move to execution. From initial discussion with Aclara to commercial design of separation circuit, which is the first step that we discussed, like the initial theoretical design and minimal test work to get to a workable concept, I think took us about 8 months. And then from that concept to an operated demonstration plan, which right now is being operated, and the first circuit is almost on spec already. That was 6 months. So 6 months from let's do a demonstration plant. We designed, built all the modules, shipped them, installed them at their Virginia Tech facility, and we are supporting them in the startup of that separation plant. In context, they're looking at over 300 stages of mixer settler in that facility, and everything is integrated, and all the recirculation and all the impurity buildup will be analyzed, validated. So I think what we've done with Niocorp and Aclara is prove that this approach can drastically shorten the project timeline. If we look at Niocorp, when Niocorp started looking at rare earths and looking at redesigning their flow sheet to add the rare earth to their portfolio because they have a very good distribution and it's fairly easy to extract from their ore, they came to us in 2021 and we had discussion about, okay, how would we do that? How would we approach that? What would the test program look like? At the end of 2024, we had already 9 months of demonstration scale facility operated from ore to pretty much commercial sample on some of the products. Again, I think the key here is speed is of the essence, and using the integrated approach really drives the schedule down.
So, speaking of speed, so one of the talking points we hear throughout the community here, and definitely those that have come on the show, is building a supply chain outside of China. One of the biggest bottleneck areas is processing. This would be the one thing that slows us down in terms of creating that resilience. So, from your perspective, where you sit in the supply chain, helping with processing, how big is that gap with the bottleneck? Is it closing? Is it not? Is it still a really big hurdle we need to overcome?
I think the biggest hurdle is capital allocation. There is a lot of money flying around and being sent left and right, but it seems that to me that the part that's missing is the expertise to be able to evaluate project and guide projects. The resources there, there's a lot of company that has tremendous talent in execution that know how to bring a project online. It seems to me, based on the flurry of investment that's been announced, that what's missing is a better capital allocation to the project that actually are more likely to make it properly. There's so much, I call it fluff, that we have the greatest technology. This is going to revolutionize everything. And you're like, it's too good to be true. And then you see 500 million allocated to that project. And you're like, the basis don't make sense yet. And then 2 years down the line, where did that go? We don't know. It's not closer to production.
You're
Project that don't do that fluff, don't boast, and just do the thing correctly. But it seems like because they don't oversell, they're not as attractive to capital market. But once these projects convince an investor, then they go to production.
you're speaking our language. And I don't know if you've read any of our articles, but we write about this all the time. And you're hitting the nail on the head, Tom. The problem is that you do not have, in quality assurance, you have something called vocational certainty, where every job description aligns nicely with the people that are put in the positions with the high salaries and the medium salaries and the low salaries. And so what's happening is you have a level of financialization. So these transactions are being driven by financiers who want bottom line return as quickly as possible. That's the first problem. So it's not being driven by the engineers or the technical talent that you need to have in place. Of course, financial, everything has its place, but yeah, we see that as a big problem and agree with you significantly. That being said, let's just take a hypothetical boondoggle project. Lots of money, lots of fluff, lots of noise. How are they doing this? They must have somebody you have to do this. So you still have to do this, even if it's a project with a lot of fluff and a lot of this and a lot of that, don't you?
Not really. Some people want to mine investors, not actual resources.
Sorry, Tom, say that again.
Something I say very often, unfortunately too often, is most project want to mine investors, not an actual resource.
Right.
See,
So-
the business model of a junior mining company, it can be broken down into two baskets. Actually, there's three business models. Business model one, which most precious metal business operated under, is let's find a resource, let's develop it just enough to sell it to a major, and then let them deal with that. That's the profit margin as to the development and then sell. It's more like a startup company that wants to sell to an established one.
Right.
The second most used business model is let's find a resource on paper, raise some money, and pay the executive team and the founders salaries for 10 years while we develop the resource. And then the third one, which unfortunately is in a lot of these companies is somewhat rarer, is let's build a mine. And to answer your previous question, I think one of the issue there, it's not that the technical expertise to make those analyses don't exist, is that a lot of the engineer that have that expertise would rather be working on the project they believe in rather than analyzing projects. So they end up at the company that want to move forward and mine.
Right. It's striking though that, again, I look at the work that you do is pretty much where the rubber hits the road as to whether something can go or not. Yeah. So let's look at the universe of customers that you could work with. So you have the junior miners that are developing new prospects and they want to try to make, see what it will actually take economically to exploit that resource commercially. There could be the private equity investors that are working with, there could be, for example, a private equity group that has a portfolio of junior mines or assets, and you're a resource that they would bring in to say, hey, we like working with L3 because this helps us. It could be, are there ever partnerships where the large majors partner with the juniors to jointly look at something, and the major might bring in a resource like yourself? Does that ever happen?
I've not seen it in the rare industry. We have to take into consideration scale of the various markets. The rare market is very important because it's a leverage point, but if you look at the balance sheet of a Rio Tinto or a BHP, this is a rounding error on their balance sheet. Like the biggest rare project would be a rounding error on for those companies. So I don't know that it's even on their radar.
Yeah, that's a good point. I think it's about a $5 to $6 billion market, which isn't very big. The magnets get up to maybe 30 billion. Of course, if you go downstream into the actual markets that consume these products, it's in the trillions eventually.
Eventually.
Yeah. So I guess, I mean, what are there other ways that your company can, let's just say, they're not ready to do a full blown flow sheet. Are there other ways that your company can get involved that might be shorter engagements, but where you can help them see things more clearly?
Yeah, that's sort of, it's a smaller part of a business. It's more a consulting type engagement that people will bring us on, either to do due diligence on partners to work with, on technology to consider, or just on how to execute the project. They might not be ready to go to execution. They might be waiting for a capital raise, or they might try to figure out what the best way to attack the market from their resource perspective is. A lot of people believe that vertical integration is the key to make this work. A lot of people think that decentralizing the various steps and having a free market at each point of the supply chain, but say in the West, is a better approach. Some of the projects that we've been involved in, basically the engagement was to try to strategize what is the best approach for this specific deposit, or other company just were interested in separation because their other business line needs a specific rare oxide and they're struggling to get the spec they need on the specific element that they need, and they believe they can get access to a concentrate that maybe has less value for somebody else. Everybody is after separating and selling the magnetic element, but there's rare that have niche application that don't necessarily get separated outside of China and may be difficult to access. So some people were working with what they want to do is essentially access those rare, and they realize that they need to vertically integrate down to separation. That they can access the concentrate, but not the individual. So we also do that type of engagement. And I guess the last one, which is the lowest amount of revenue for us, but one of my most important stream of engagement, is the university circuit and the government type work. From a revenue perspective, it's not significant, but I think the thing that gets overlooked the most in all the discussion, almost across the board all the time, is talent. Like, how many people have expertise to even execute project in this field, and how many are going to retire within the next 5 years? What then? So we take that very seriously, and we have partnership with different universities specifically to figure out how can we mine talent and how can we build a pool of people that can join our company and essentially know what they're doing and supply that talent to the market. Because to me, that is one of the most underappreciated aspects of the full industry. If we look at China, what they've done, they have at least 2 full universities that are dedicated to rare processing.
There's no comparison, and we're so aligned in so many ways, Tom. I'm so glad that we found each other, because so much of what you're saying is we just repeatedly put out there all the time. Let's talk about the talent pool for a minute. Based on that, and that sounds really smart for your firm to partner with universities and both educate, develop a pool of talent that both you could use and others. Where are we at? If you look at the spectrum of talent readiness, people retiring and the different roles, whether it's chemical or engineering, how far off are we based on your assessment? How many relevant engineers are we generating per year that could fall into this line of work, and how many do we need?
Not looking good.
Talk to us a little bit about that.
I'd have to check what the latest is. I think there's 7 or 8 mining departments that do metallurgy in the US. I think there are 3 or 4 in Canada. And even top universities, you're talking a handful of graduate per year that even study technology metals. It seems to be more in vogue now, but even if you go to capture 30% of a metallurgical engineering department, it's a rounding error on the engineering scale.
Right.
There's very talented people, there's very good programs and professors. I think the problem we have is, one, it's a niche application, and two, everything's done in China. So how do we foster the ecosystem to send people in that pipeline is probably one of the key challenges that we have to face and figure a solution.
Yeah. And that part, we would like to speak with you about maybe having some sort of conference online about this topic. Get a few universities, yourself, others. I think it's an important topic. So Dustin, I think, as we get close to the end top of the hour here, are there any last questions that you have?
I think one that we could probably wrap up on with Tom is, you've been in the industry for a number of years, but where do you see things going over the next 5? What are some of the greatest opportunities that you foresee? And adversely too, what would you say are some of the biggest unresolved challenges still over the next 5 years?
I mean, it's rare. So it's a game of politics. How do you prevent a flooring of the price as political strategy? And what government would have the political incentive to protect a small, negligible industry if that were to happen over, say, 5-year period? The instinct is, okay, let's make a scenario. Assume all the prices are going to be cut by 4 next year because the world market opens. 1 year, okay, the government say, we're going to step in. We want to protect the industry that's about to start, that is in the process of starting. We're going to put floor price for a certain amount of production. Okay, I think there's going to be political willpower to do that. Year 2, yeah, maybe. 4 years down the line, the market price are, say, 2x lower than the production price in North America. How long are we going to sustain the industry before the government decide that it's not politically sustainable to finance an industry? And at what volume do we want to finance the industry? And then as soon as the subsidies in that scenario stops, then what happened to the industry? Does it collapse within a year and then we're back to square one in 10 years? And I don't have a solution to that. I don't know what the political solution, what the structure needs to be. It is one of these very complex problems that, as a sort of Damocles, essentially above the head of everybody in this industry.
Well, real quickly, I would just chime in. I mean, there's real trouble if we don't, because as you know, with just the heavy rare earth elements and the sort of bottleneck there, I mean, if China decided they just need all of their product for themselves, and they're almost there anyway, they're priming the pump of demand for their own industries. We were really out of luck. Literally, certain products will have to go back retro 10, 20 years. We'll have to design products that are 20, 30 years old. They work, a missile that's a few pounds heavier is still going to do some damage, but you know what I mean? But I don't think that's where we want to go. I don't think we want to say, okay, let's stop all of our product development, go back 15 years, get rid of the miniaturization. So I don't think there's really an option. I think that it will be important for firms like yours. I mean, the economics of all this, we believe strongly we need an industrial policy that provides support for some of these critical projects ongoing for a decade, because you're going to need that financial support. Otherwise, you can't compete with China.
I think you just said it. I think we need to separate heavy rare earth from light rare earths. I think the market will need to figure out a way so that the firm in the West can be competitive. I think the volume in the heavy rare and the amount of money required to sustain the supply chain are small enough that is probably something that could have policy support that could be unwavering. On the light rare earths, I'm not sure. I'm not sure it's possible. The volumes are much higher, and it's easy to get light rare earths and separate them and make product out of them, technically. It just becomes a political will, essentially, to obfuscate some of the radioactivity obstacle. If Mountain Pass was not in its jurisdiction and was in an easier place to operate, they would have a lot less problem, and they'd already produce a lot more.
Yeah. Really, really important points you're making.
And Tom, we are at the end of our time here. So we thank you so much for sharing your insights and perspective. I think there's a lot of thought-provoking stuff here, from the efficiency of processing to talent pool needs and requirements, along with the geopolitical strains that can impact any operation. So lots to think about here for sure as we move forward. Thank you again for being on the show. I think this was a great conversation, and I think a lot of people will appreciate it when it comes out.
Thank you. This was very fun.